Assalamualaikum and hi. Last week is the final week for the first chapter, which is reinforced concrete beam design. This week we're going to start with reinforced concrete column design. So column, a function of column is a structure is to act as vertical support to suspended members such as beam and roof and transmit the loads from these members down to the foundation. Meaning to say any loads that come from above, maksudnya daripada atas, daripada column, because we have roof and also beam. Okay, beam ni pula mungkin dia punya load datang daripada slab. Okay, slab transfer to beam. Okay, and then the beam will transfer to the column. Okay, and roof daripada roof trusses, dia akan pergi pada beam and so on, pergi pada column lah. Okay, column are primarily compression member, although they may also resist bending moment transmitted by beams. Column ni dia actually berdiri tegak like this. So mostly the loading yang come from above is basically axial load ataupun load jenis lain lah. Axial load meaning axial tu maksudnya betul-betul dekat tengah. Also mungkin dia juga ada resist bending moment transmitted by beam because of beam perhaps will come from here. Okay, so beam ni akan transmit. So basically ada moment daripada beam ni akan transmit pada the column. Okay, column may be classified as short or slender. Maksudnya column jenis pendek ataupun column yang jenis kurus dan tinggi. Braced or unbraced meaning dia ada support, extra support or not, and depending on various dimension and structural factors. So ada many types of column. Common column cross section are square, circular and rectangular section. You can refer to this figure. So we have square, round and rectangular. The greatest dimension should not exceed 4 times its smaller dimensions. For a square column dengan round column like this or circular column, this one not apply lah. But basically this is for C here, which is the rectangular section. Let's say H here is less than or equal to 4B. Meaning contohnya you have B equal to 200 and H is equal to 800. When you multiply 200 with 4, because you kira 4B kan, so 4B part darab 200, you will get 800. Tengok you punya H, you compare dengan value of H. So H here we put 800, so it means it is equal lah. Equal ni, less or equal lah. So dia equal meaning kita consider dia as column. Okay, tapi if let's say H is bigger than 4B, kalau H ni perhaps you tukar jadi 900. So H is bigger than 4B sebab H adalah 900 and 4B you adalah 800. So 900 is bigger than 800. The member should be regarded as wall for design purpose. So walaupun dia adalah column, you nampak dia macam column, tapi bila you design, you're going to treat it as wall. Okay, we have here failure modes of column. There are 3 mechanisms, which is compression failure of concrete or steel reinforcement, buckling and combination of buckling and compression failure. Okay, for the first one is compression failure. This one normally, okay, kalau you tengok dekat bawah ni, compression failure 1 is most likely to occur with column which are short and stocky. We have the example of stocky and short column. Why this happen? Normally because of perhaps you tak provide, ini adalah contoh lah, material failure. You tak provide size yang bersesuaian and mungkin concrete punya strength also tak betul, steel strength also tak betul. Maksudnya you design dia not according to the load yang being transferred. Maksudnya ada salah dari segi design, failure in concrete or steel reinforcement. Ataupun mungkin juga kalau you tak provide link ataupun kita panggil juga dia as tie. Maksudnya link ni kita panggil dia tie juga. Kita boleh juga panggil dia binder. Dia benda yang sama tie atau link. Binder. Okay, you tak provide binder yang sebetulnya lah. Itu akan menyebabkan failure yang macam ni And buckling, okay, sama je basically why it happen. But this normally happen to long and slender column. Column yang lebih tinggi ni, that's why when kita design, kita kena consider whether that column is slender or short and stocky column. Bila kita tahu which type of the column, so that we know how we going to design the column And also last kali is a combination of buckling and compression failure. Because we need to check whether macam mana kita nak design, maksudnya kita nak design dia as short ataupun slender column. Jadi kita kena classifykan column ni yang mana satu, baru kita boleh start design. To identify it, there is a formula here. Column is classified as short if LEX divided by H is less than 15 and LEY divided by B is less than 15 when braced. But when unbraced, LEX divided by H is less than 10 and LEY divided by B is less than 10. What is LEX? What is LEY? LEX and LEY is actually effective height, but depends pada dia punya axis. Normally kita akan cakap x-axis tu adalah major axis lah. Maksudnya axis yang paling penting. Kalau tengok dalam drawing sekalipun, you ada drawing, you akan perasan ini adalah paksi X dan ini adalah paksi Y. What is effective height? So effective height ni sebenarnya dia tak sama macam height. To get the effective height, you have a formula. Okay, macam mana kita nak kira effective height? Actually, it depends on the end support of column tu macam mana. Maksudnya sambungan column tu macam mana. Katakan you dapat effective length yang lebih rendah, lebih bagus. Maksudnya dia akan kurang buckle. But effective length yang lebih tinggi, dia lebih senang untuk buckle. Bila nanti kita akan tengok on the effective length punya cerita. Okay, dalam tu nanti you akan nampak, you kena darabkan dengan factor. Okay, so factor tu depends pada end support dia macam mana. Sama ada end support dia monolithic or not, that kind of thing Jadi kita kena tengok on that. Itu adalah effective length. What you have to know is like effective length ni maksudnya macam dari segi design Ini bukan dari segi whatever you might see physically. Effective length ni adalah length yang you darabkan factor because of you want to know what will happen to the column bila you put on load on it. Macam tu. So maksudnya length yang akan buckle. Length yang ter-effect untuk buckle. For X, we have to divide it by H here. Dari segi XX, maksudnya column you akan panjang ke bawah This is actually plan view as in the column is standing straight, tall. Then you akan tengok daripada atas lah. Length tu adalah tinggi column dia. Bukannya dari B ataupun H yang you nampak tu, dimension dia tu. I nak explain about yang tadi kita cakap braced dengan unbraced column. Column may be considered braced if the lateral load due to winds, for example, are resisted by shear wall or some other form of bracing rather than a column. Okay, kalau you tengok dekat sini, there is no shear wall. So this one we might consider it as unbraced. However, if you look at here, figure 3.87 ni, it is unbraced in X direction. Okay, maksudnya X direction ni, X ni tak unbraced. But in Y direction, it is braced. It also can be braced in both direction. Contohnya, you have shear wall in the middle like this. Normally, kalau you pasang shear wall ni, normally kalau ada lift, kan, elevator, normally it is shear wall Jadi, pasang shear wall, jadi it also consider column-column yang lain-lain ni adalah brace. Okay, in both direction because of shear wall. Untuk lift mungkin dekat tengah-tengah ataupun you ada core dekat tengah-tengah tu for the sake of bracing. Kalau you tengok dalam gambar ni okay, unbraced frame, lateral load must resist and transmit down to the foundation by interaction between beam and column frame members. And this one adalah brace frame. Nampak ada dia panggil brace B kat sini. Okay, lateral load transmitted down to foundation through a system bracing or shear wall. Lateral load yang transmit pada shear wall. Okay, column only transmit axial load. Dia tak terganggu dengan lateral load. Lateral load tu contohnya macam angin, anything yang macam horizontally. Shear wall yang akan transmit. Shear wall ataupun brace B itulah yang akan transmit pada foundation. This one baru I cerita pasal effective length. The formula we have LE, this is the one yang I told you. B and darab dengan LO. B ni adalah factor tadilah, function of fixity at the column end, tapi dia adalah factor maksudnya you kena darabkan dengan something nombor based on fixity at the end of the column. LE effective length, so depends lah arah Y atau arah X, and you have clear height between lateral distance, so maksudnya height of column lah, nak sampai ke beam tu berapa height dia. We look at here, and condition 1 signify that the column is fully restrained. The first one, kalau tengok fully restrained. Okay, the second one adalah partially restrained, and the third one adalah nominally restrained, maksudnya restrain yang paling kurang lah. Dia ada 3 jenis. Kalau you nampak kat sini, there is end condition at the top. Okay, 1, 2, 3. Ini end condition at bottom Maksudnya macam mana dia connect dengan, maybe dia, sebab dia akan connect dengan column below lagi kan, kalau you ada buat bangunan bertingkat-tingkat, ataupun dia akan terus connect pada foundation. For this one end condition at top, macam mana dia connect mungkin pada the beam and ada column lagi ke atas, how dia akan connect on that So end condition number 1, the end of the column is connected monolithically to beams on either side which are at least as deep as overall dimension of column in the plane considered. Dekat sini, you have the column and then you have the beam here. So you akan tengok yang belah bawah, sebab sekarang kita tengah tengok end condition yang bawah Both side adalah on this type of end condition So where the column is connected to foundation, it should be designed to carry moment. So depth of beam is bigger than depth of column. So apa maksud dia? Beam you punya depth, you know, we have B. So this is beam. Okay, and depth of column, you ada arah X and ada arah Y. So berapa ni? Kalau depth of beam ni lebih besar daripada depth of column. So depth of column tu you kena tengok you buat arah mana lah. Kalau you buat untuk LEX, you akan tengok arah X punya depth lah, which is B. Okay, which is B, you akan tengok B of column ni you akan comparekan dengan height of beam ni. So kalau dia lebih besar daripada depth of column, dia adalah end condition 1. End condition number 2, if the end of column is connected monolithically. Monolithic ni, kat sini ada kata monolithic. Oh, I tak explain. Monolithic ni maksudnya dia menjadi satu. As in, dia very rigid lah. Beam, column, you concrete together. So dia monolithic Ataupun slab. So you akan concrete together. So dia monolithic So the beam of column is connected, becoming one, to beams or slab on either side which are shallower than overall dimension of the column in the plane considered. So depth of beam ataupun slab, beam atau slab ni So reinforced concrete slab kadang-kadang ada juga kita tak pakai beam. Okay, so maksudnya slab tu sendiri yang duduk dekat atas column. So beam ataupun slab ni, apa-apa yang connected dengan column ni lah, dia less than depth of column. Kalau you tengok sini, bigger. Okay, yang end condition number 1, this one bigger. This one dia less lah. Dia adalah end condition number 2. And last kali we have end condition number 3. The end of the column is connected to member which, while not specifically designed to provide restraint to rotation of the column, will nevertheless provide some nominal restraint. Maksudnya dia not being designed monolithically. Bila you refer on this one, so you will know which one conditionnya. Okay, contohnya kalau you have both side fully restrained, which mean in the condition number 1, you akan ambil this one. But if you have like and condition at the bottom ni, maksudnya column dengan beam dekat bawah sambungan dia lain, and column dekat beam yang atas sambungan dia jenis lain-lain, you akan select yang berbeza-beza ikut this table. For the syllabus that we're going to learn in regards to PJN 242, we only covered short brace column design. Kita takkan masuk on the slender column, kita just belajar short brace column design, macam mana cara nak kira. So for design purposes, BS 8110 ni ada 3 category of short brace column. The first category is short brace axially loaded column. We look at that. B2 will resist axial load as it supports beam equal in length and symmetrically arranged. So kalau you tengok dalam gambar rajah ni, B2 ni kita panggil dia as axially loaded column only because of dia punya loading adalah symmetry, maksudnya betul-betul dekat tengah-tengah lah. So it is only axial load sahaja. For the second one is short brace column supporting and approximately symmetrically arrangements of beam. For this one, you look at C2. Column C2 just support symmetrically arranged beam. Tapi if you notice here, this beam lebih panjang compared to others. Dia resist axial load and also provide moment provided that the loading of the beam are uniformly distributed. Meaning beam ni dia punya load adalah uniformly distributed, jadi dia transfer tu memang uniform transfer. And the beam spans do not differ by more than 15% of the longer the moment will be small. And another one, last kali, we have a short brace column supporting vertical loads and subjected to either uniaxial or biaxial. So kalau condition A dengan B, maksudnya condition A yang macam ni, maksudnya dia symmetrically arranged and also sama saja panjang-panjang beam dia. Okay, jadi dia adalah condition A. Okay, tapi kalau condition B macam C2 sini. Okay, ni B2 ni C2 untuk condition A and B. But for condition yang last kali which is column resisting axial load and uniaxial or biaxial ni, okay, the moment here becomes significant and the column may be required to resist. So dia kena resist beberapa termasuk moment and axial load and uniaxial bending. Okay, kalau you tengok condition yang ni and axial load and uniaxial bending, for example you have like B1, C1 and then you ada B3 and C3. Okay, you tengok sama je, dia ada like 3 beam yang connected, and then you have A2 and then you have D2. Look at column D2. Paksi Y memang simetri sebab atas dan bawah ada beam yang sama panjang. Tapi paksi X, beam yang belah kiri sahaja yang ada. Okay, belah kanan tak ada beam. Jadi dia tidak balance. Untuk X-axis, loading tu memang axis untuk arah Y. Tapi arah X, loading tu dah lebih ke kiri. That's why for Y-axis dia panggil axial load, tapi for X-axis dia akan panggil uniaxial. You have another one which is an axial load and biaxial bending, which is A1, A3, D1 and D3. Let's take A1 for example. If you see that paksi X dengan paksi Y dua-dua memang loading dari beam tu akan lebih ke atas dan juga akan lebih ke kanan. Sebab belah kiri tak ada beam dan belah bawah pun tak ada beam. Jadi ada biaxial
sebab ada dua axial yang tidak balance.
In our syllabus, kita belajar yang the first one saja, which is short brace axially loaded column. This one, axially loaded column, the one yang we covered, this is the formula. Equal to 0.4 FCUAC plus
0.8.
FYASC. Saya rasa you dah familiar lah dengan what is FCU and FY Tapi AC dekat sini, tengok net area of column. Maksudnya dia adalah area of concrete. And ASC here is area of longitudinal reinforcement. Maksudnya main bar lah. Kenapa kita panggil dia longitude? Because of column dia ke bawah like this. Bar will be like this, around like this lah. So you have a longitude yang memanjang ke bawah. Jadi it is a longitudinal reinforcement. Okay, and here is ultimate axial load, which is berapa loading yang boleh disupport lah kalau you ada concrete strength macam ni, steel strength macam ni, and area of concrete macam ni, area of steel macam ni. Jadi axial load berapa yang dia boleh support. So that is the formula. In column tak banyak formula Masih sama strength of reinforcement, high yield steel, mild steel 250 to 60 masih sama. We are going to refer to this one also. And concrete compressive strength masih sama. And we also going to use the same table, which is cross section area of bar kalau kita nak cari area of steel. Ada requirement for links. The diameter of link should not be less than 6 mm. 1/4 of the diameter of the largest longitudinal bar. The diameter of link, bar size ni you faham lah. So kalau kita kira link
Ataupun tie, binder atau shear reinforcement, benda yang sama
Bar size adalah 1/4, 1/4 of the diameter of the largest longitudinal bar. 1/4, 1/4 daripada diameter. Diameter apa? Diameter main bar lah ataupun longitudinal bar. Untuk bar size ni, ini adalah minimum size Maksudnya tak boleh kurang daripada value ni. And also kalau you perasan kat sini, it says also 6 mm. Maksudnya kalau katakan diameter you contohnya 12 mm. Okay, diameter of longitudinal bar. So you kira 1/4 darab 12 mm. So you dapat 3 mm. Tapi it state here that 6 mm ni adalah minimum. Okay, jadi you dapat macam ni, tapi you kena pakai 6 mm. Sebab size bar tak ada lagi rendah daripada 6 mm. Okay, kalau you tengok pun dalam this one, okay, you nampak bar size 6 mm paling rendah You cannot go lower than, you cannot put 3 mm. And if 1/4 times, perhaps you punya ni 32 mm. So 1/4 darab 32 adalah 8 mm. Okey lah, so kita akan pakai 8 mm sebab 8 mm lagi besar pada 6 mm adalah the minimum size You dapat rendah, you ambil 6 mm. You dapat lebih, pakai value tu. Okay. And also another one, kat sini ada juga state about spacing maximum. Link punya spacing tu lebih rapat, lebih bagus Jadi maximum spacing tak boleh lebih besar pada value tu. Sebab kalau lebih besar spacing dia terlampau jauh. So kurang bagus lah. The formula is 12 darab diameter. Diameter apa? Diameter of longitudinal bar. Okay, kenapa ada perkataan smallest, largest? Because of sebenarnya kalau kita design for column, kita boleh mix diameter bar tu to fulfill area yang we need. Katakan you have mungkin combination, mungkin you pakai ini adalah 16, mungkin you perlukan sampai 8 Okay, you can put like 12 mm kat sini. Depends 12 mm and 12 mm. Semualah mesti samalah. So this one 16 mm and 12 mm dia combine. Boleh. Jadi bila you combine bar macam ni, kalau spacing you akan pakai paling kecil punya, maksudnya pakai 12 mm. Bila you kira dekat sini, maksudnya you kira the diameter ni, you akan dapat some value lah, which is what, 144 But kalau you kira for minimum size link ni, okay, you kena pakai largest longitudinal bar. Okay, maksudnya kat sini you darab 16 mm lah contohnya.
That will be all for today. We're going to continue during another 1 hour of the lecture class. Thank you so much everyone. Have a nice day.